Hello everyone, this is Adwik Gore. Welcome back to our channel Info Aviation. This is our second video, so please subscribe and like. This video will be interesting as you will learn basics and some advanced topics about planes. So let's get started. The lift is generated by each part of the plane but mostly by the wings. Lift is a mechanical aerodynamic force produced by the motion of the plane through air. Lift acts through the center pressure of the object and is directed perpendicular to the flow of direction. Now the plane has three main or primary controls: the ailerons, stabilizers or elevators, and the rudder. The ailerons are mounted on the trailing edge of each wing near the wingtips and move in opposite directions. When the pilot moves the joystick towards the left aileron goes up and the right aileron goes down. It happens opposite when the pilot moves towards his right. A raised aileron reduces lift on that wing and a lowered one increases it. So moving the joystick towards the left causes the left to drop and right to rise. This causes the aircraft to roll towards the left and now begin to turn toward the left. Now the second, elevator. The elevator is a movable part of the horizontal stabilizers hinged to the back of the fixed part of the horizontal tail. The elevators move up and down together. When the pilot pulls the joystick backwards, the elevators go up. Pushing the stick forward causes the elevator to go down. Raised elevator pushes the tail down, causing the nose to rise. This makes the wings fly higher angle of the attack, which generates more lift and more drag. Now what is angle of attack? Angle of attack is the angle at which moving air comes into contact with the wings. Now the rudder. Guys, if you are getting bored, please bear with us as this knowledge will help you in the future videos. This will be extremely interesting. So let us continue. Rudder is typically mounted on the trailing edge of the vertical stabilizer part of the impingement. When the pilot pushes the left pedal, the rudder deflects left. Deflecting the rudder left causes the tail to go right and the nose to yaw to the right. So now I would request aviation enthusiast Tilak Mistry to continue and tell us about the APU, the RAT and the hydraulics.
Thank you very much, Adwik. So let's continue. An APU or auxiliary power unit allows plane to operate autonomously without reliance on ground support equipment such as GPU or an external air conditioning unit or a high pressure air start car. The APU is generally a small jet engine which is normally located in the tail cone of the plane, but in some cases is located in the engine nacelle or wheel wall. The APU can be started utilizing only the plane batteries and once running will provide electrical power to aircraft systems as well as bleed air for air conditioning and engine start. When the APU is certified for use in flight, the APU can be used as required to provide an additional source of electric power in an engine of loss of an engine generator. It can also be used as a source of bleed air for starter assist and in-flight engine relight or to power the air conditioning packs in the event of conditions. But company policies dictate that the takeoff will be conducted with the bleed air turned off. Now let's go to the second part, that is RAT, that is ram air turbine. Modern planes generally use RATs in emergencies in case of loss of both primary and auxiliary power sources. And RATs will power the vital systems like flight controls, linked hydraulics, and in-flight critical instruments. Some RATs produce only hydraulic power, which is in turn used to power electric generators, and in some old aircrafts, even airships, small RATs were permanently mounted and operated by electrical generator or fuel pump. Some constant speed propellers such as those of the Argus AES 410 engines used Focke-Wulf FW 189 used propeller turbine on the spinner to power a self-contained pitch governor controlling the airspeed. RATs generate power from airstream due to the speed of the aircraft. If the aircraft speeds are low, the RAT will produce less power. In normal conditions, the RAT is retracted from the fuselage, that is the body, or from the wing, and is deployed manually or automatically following complete loss of power. Power is engine power and auxiliary power. Now, third, hydraulics. Hydraulic systems are used on aircraft to move an acute landing gear, flaps, brakes. Larger aircraft use these systems also on flight controls, spoilers, thrust reversers, and whatnot. Means it is in short used everywhere. The reason to use hydraulics is because they are able to transmit very high pressure of force with a small volume of hydraulic oil. Power assisted brakes is one application where you say hydraulics. The most is small experimental as and ultralight aircraft. They are very reliable. Its fluid is virtually incompressible and transmits high pressures but not lightweight compared to the mnemonic systems. Usually, aircraft builders will put their brake systems themselves, so it is helpful to gain the understanding of how hydraulics work and how to handle it safely during installation of maintenance. Now, I would request an aviation enthusiast and one of my best friends, Sushant, to continue. So, Sushant, please continue.
Thank you very much, Tilak. So let's continue. Now there are four secondary axes: spoilers, flaps, slats, and air brakes. So let's start with the spoilers. On low-drag aircraft such as seaplanes, spoilers are used to disrupt airflow over the wing and greatly reduce lift. This allows a glider pilot to lose altitude without gaining excessive airspeed. Spoilers are sometimes called lift dumpers. Lift dumpers. Spoilers that can be used asymmetrically are called spoilerons and can affect aircraft's roll. Now this was about spoilers. Let's go to flaps. Flaps are mounted on the trailing edge on the innerboard section of each wing, near the wing roots. They are deflected down to increase the effective curvature of the wing. Flap raise the maximum lift coefficient on the aircraft and therefore reducing stall speed. Now what is stall? Stall is the slowest speed at which the plane can fly. Now back to flaps. They are used during low speed, high angle of a type flight, including a takeoff and descent for landing. Some flights have innerboard flaperons, which are called innerboard ailerons. These devices function primarily as ailerons, but on some aircraft will drop when the flaps are deployed, thus acting as both a flap and a roll control innerboard aileron. Now to slats. Slats, also known as leading edge devices, are extensions to the front of the wing for lift augmentation and are intended to reduce the stalling speed by altering the airflow over the wing. Slats may be fixed or retractable. Fixed slats give excellent source speed and stall capabilities, but compromise higher speed performance. Retractable slats, as seen in most airlines, provide reducing stalling speed for takeoff and landing, but are retracted for cruising. Now finally, air brakes. Air brakes are used to increase drag. Spoilers might act as air brakes but not pure brakes, as they also function as lift dumpers or in some cases as a roll control surfaces. Air brakes are usually surfaces that deflect outwards from fuselage, in most cases symmetrically on the opposite side into the screen, in order to increase from drag, as they are in most cases located elsewhere on the aircraft. They do not directly affect the lift generated by the wing. Their purpose is to slow down the plane. They are particularly useful when a high rate of descent is required. They are common in military aircraft and small civil aircraft. So that all was for the day. Please subscribe our channel and like our video. Aviation is the future. Aviation will be everything. This channel is dedicated to make aviation safer. Thank you.